So we've got another example of optimization. In this problem, they ask us, consider the function f of x equals 9 minus x squared, which is this blue line graphed. Okay? And they only want us to consider it when f of x is greater than 0. Now it says, let t of x equal the area of the shaded isosceles trapezoid that has two vertices on the x-axis. Okay? What is the maximum value of t of x? Now, if you notice, the vertices of the trapezoid fall right on the x-intercept of the function, here and here. Okay? But let's first talk about what is the area formula for a trapezoid. Area formula for a trapezoid is 1/2 base 1 plus base 2 times the height. And so those are the things you need to evaluate. What is base 1? Okay, what is base 2? And what is the height? Now, here is base 1 right here, and base 2 is this on top. Okay, now base 2 is really easy to tell what it is. Okay, the length from the y-axis to the end of base 1, this length right here is x, right? We're saying we go over x and then up f of x. And so if that's x, right, then the whole top, this whole top section will be 2x. Okay, so we'll say base 1 equals 2x. Now we need to figure out what base 2 and what the height are. Now the height is f of x, isn't it? Okay, you go right x, you go right your input, and then you go up your output, which you plug into the function f of x, and so your height is going to be 9 minus x squared. Okay, but the hard part is figuring out what is the length from the origin out to here. Well, whatever the x-intercept of our function is, would be this point, wouldn't it? So let's take our function 9 minus x squared, and let's set it equal to 0 and see where the two x-intercepts are, right? If I solve that for equal to 0, it's going to tell me the x-intercept here, and it's going to tell me the x-intercept here. So I'm going to add x squared to both sides, and so I have 9 equals x squared. Then I'll square root both sides, and so x equals 3 and x equals negative 3. And so what we're saying is, this is the point negative 3, x equals negative 3, and this right here is the point x equals positive 3. Now the function tells us only deal when x is greater than 0. So the length from 0 to 3 is how many units? 3. Okay, and so the entire base is 3 plus 3, which is? 6. So the entire base is 6, and so base 2 equals 6.
And then you plug that into height, though, you get 0.
So now we've got all the important information. We've got base 1, the height, and base 2. So let's plug them in. And I'm not going to call it area because the problem told me to call it t of x. So I shouldn't have put an a here. I should have put t of x equals there. So I'm going to say t of x equals 1/2 base 1, which is 2x, plus base 2, which is 6, times the height, which is 9 minus x squared. And now that's what you're going to optimize. That's your function. We need to multiply the function out, find the derivative, and that's what we're looking for the max of. So I've got t of x equals 1/2, and then I'm going to FOIL this. 2x times 9 is 18x, and 2x times negative x squared is negative 2x cubed, and 6 times 9 is 54, and 6 times negative x squared is negative 6x squared. Okay? And now I'm going to distribute that 1/2. And so I've got T of x equals, excuse me.
We're taking a test.
All right, so I'm going to distribute the 1/2. So I've got T of x equals, and I'm going to 1/2 of, I'm going to look at my highest degree term first. 1/2 of negative 2x cubed would just be negative x cubed. And then I'm going to look at the next highest degree. 1/2 of negative 6x squared would be negative 3x squared. And then 1/2 of 18x would be plus 9x. And 1/2 of 54 is what, 27? And so that's your function that represents what we're looking for. What we want now is the derivative of it so we can maximize it. Now, remember they want us to do it over the closed interval 0, 3. Okay? So we're going to have to test 0, we're going to have to test 3, and we're going to have to test our critical number. And whichever one gives us the highest output, that'll be your maximum. So I've got T prime of x equals negative 3x squared minus 6x plus 9. And so that's what I've got to set equal to 0. Before I do, I'm going to factor out a negative 3. So I've got T prime of x equals negative 3 times x squared plus 2x minus 3.
Why are you factoring out a negative 3?
Just to make it easier to solve. And so now all I have to solve is I'm going to take x squared plus 2x minus 3, and I'm going to set it equal to 0. I could take the negative 3 and set it equal to 0, but that doesn't provide you a solution. And so that will factor, so I won't have to use a quadratic formula. Okay, x plus 3 and x minus 1 equals 0. And so you can see that x equals negative 3 and x equals positive 1 of your critical numbers. Negative 3 falls outside of the what? The range, or the domain, yes, good, the domain. And so your critical number that's usable is 1. Okay, and so now what we need to do is we need to test 1, 0, and 3, and whichever one gives us the highest output, that's going to be your answer. Okay, so let's look at our original function. Right, our function that we're plugging into is this one right here. And so I'm going to evaluate T of 0. I'm going to evaluate T of 1. And I'm going to evaluate T of 3. Because here's what we're looking for. We're looking for the maximum in a closed interval 0 to 3. So we got to test the left endpoint 0, the right endpoint 3, and then the critical number. And whichever one gives us the highest output, that'll be the answer. T of 0, so when you plug 0 into this function,
27.
All these go away, just leaving you 27. Good. 27. Okay. Let's plug 1 into the function. So to give you negative 1,
32.
and negative 3 is negative 4, right? And that's 9. 9 and negative 4 is 5, plus 27 is good, 32. And so I've got 32. And when you plug 3 in, so when we plug in 3, right here we get negative 27, and right here we get negative 27. But here we get positive 27, and here we've got positive 27, so all of it equals 0. Okay? And so your max is going to be here at T of 1, which equals 32. And so the question asks, what is the maximum value of T of x? Well, we got that the maximum value of T of x was 32. And so our answer on this question, answering the question they ask right here, would be 32.